All right, guys, this is the second assignment for the week. This is the application problem. So you should have hopefully viewed the videos about people like launching rockets and stuff like that. So a couple of contextual words that are going to signal our brains to figure out how to solve and go about this problem. So it says the path of a toy rocket launched from a platform is modeled by the function. It gives us our equation right here. We're already in standard form. H is going to represent height in feet. And then t is going to represent time in seconds since the rocket was launched. It says after being launched to the nearest thousandth of a second, that's important, nearest thousandth of a second, when will the rocket hit the ground? All right, so a couple of important things there. So I like to draw a picture first. All right, so I just have a little grid right here. I know that my x-axis is time, and it's in seconds. I know that my y-axis is height, and it's in feet. All right, so if you remember, we learned about this a little bit. This 4 is how high the rocket was when it launched. It's that initial height. Right? So if I want to, I can make my drawing somewhat accurate. Like it doesn't start on the ground. It starts at a height of 4. It's like getting launched off a platform. And then you launch a rocket up, and then it comes back down and it hits the ground, right? The ground will be a height of 0. What this question says is how long does it take for it to hit the ground? So I'm looking for this coordinate point. I'm looking for that point right there, which hopefully you know is an x-intercept, right? I don't care about the maximum height or how long it took to get to the maximum height. I don't care about the vertex. I care about when it hits the ground. That's that x-intercept. All right, a couple different ways we can do this. We can factor it. We can use the quadratic formula. We can complete the square. I'm telling you right now, the easiest way when you're getting into these problems, when you're finding the x-intercepts, is always use the quadratic formula. It is the only method that works every single time. All right, so x equals opposite of b plus or minus the square root b squared minus 4ac all over 2a. I guarantee this answer is probably not going to be pretty. When you launch a rocket, it doesn't always land exactly after 4 seconds. It's going to be like 4 seconds and some change or something like that. Okay, so I'm going to come back down here. I'm going to write down my equation. I have h of t equals negative 16t squared plus 96t plus 4. All right, good news is I'm already in standard form, so I can go ahead and label A, B, and C. A is a negative 16, B is a 96, and C is a 4. All right, so I'm rounding to the nearest thousandth of a second. So when I do this, I'm going to be giving an approximate solution. So I don't need to worry about doing a factor tree and all that stuff to get an exact solution because it tells me what to round to. All right, so I'm going to come down here. I'm going to plug all my A, B, and C's into my formula. X equals the opposite of B. B was a 96, so it's a negative 96 in my formula. Plus or minus the square root. We have B squared minus 4 times A times C, and that is all over 2 times A. All right, doesn't change. We've done this a billion times, so hopefully you guys are getting more comfortable with the quadratic formula. Hopefully you know that the part that you do next is the discriminant, everything under the square root sign. All right, so I get x equals negative 96 plus or minus the square root. And I'm going to type this in now. So we have, in parentheses, 96 squared. It's a pretty big number, minus 4 times a negative 16 times 4. And we get 9,472. And that is all over negative 32. Right? 2 times the negative 16 is that negative 32. Okay, so this is where it's going to get a little sloppy. But the good news is we're giving approximate solutions, so don't make this more difficult than it needs to be. If you take the square root of 9,472, we do not get a nice number. We get an irrational number, a number that doesn't terminate, the decimal keeps going, and it doesn't repeat. All right, so what I'm going to do here is I'm now going to break into my two problems. So I'm going to solve, let me get a different Sharpie here. I'm going to do negative 96 plus the square root of 9472 over negative 32. I'm going to type this all into my calculator very, very carefully. Do the numerator first. So I'm going to do negative 96 plus the square root of 9472, press enter, and then divide that by a negative 32, and we get negative point, and I'm rounding to the nearest thousandths, that's 3 numbers after the decimal place, 0, 4, 1. So now let's look at this solution. Does that make sense? Can you launch a rocket and it land negative 0.041 seconds later? No, it does not make any sense. That is called an extraneous solution. So it's a solution, but it's not a solution that actually makes sense. All right, so I'm guessing my other solution is going to be the correct answer. So I take negative 96 and I'm going to subtract the square root of 9472 all over negative 32. All right, so negative 96 minus the square root of 9,472, press enter, and then divide that by a negative 32, and we get 6.041. And my units are seconds. This is the correct answer. 6.041 seconds is how long it takes that toy rocket to reach the ground. Guys, once again, make sure you are showing all of your work. It should look like this. If you're using some sort of app or something to help you out, that's great to check your work. But I am looking for all of this material. You're just doing one quadratic formula example. All right, we are going to now move on to the last question of your assignment number 2. That is the javelin throw. So it says that the javelin throw is a track and field event where athletes throw a javelin spear through the air. For one athlete, the path of javelin can be modeled by the following equation. X is going to represent horizontal distance in meters, and the javelin travels from the thrower, and Y is the height in meters of the javelin. How far from the athlete will the javelin land? All right, so let's draw a picture. Always like to draw a picture to make sure I know what I'm solving. All right, so this is distance that he's throwing it, and it's in meters. And then this is height, which is also in meters. All right, so once again, if you remember some stuff about our standard form quadratics, this is the initial height. It's the initial height. I should write that first. Initial height. All right, so he's throwing it 1.5 meters off the ground. That's like what? 5 feet-ish. All right, so he throws it 5 feet off the ground, javelin goes, and then eventually it hits the ground. So we're looking for the distance the javelin has traveled. In a sense, we are looking for, once again, the x-intercept. If you guys haven't realized it yet, this entire week is on the quadratic formula, so we are probably going to use the quadratic formula to help us, just like the last example. All right, so we have x equals opposite of b plus or minus the square root b squared minus 4ac all over 2a. All right, my equation is y equals negative 0.004x squared plus 0.35x plus 1.5. So it looks scary, but once again, guys, the calculator does all of the work for you. You just got to make sure you're careful when typing it in. All right, a in this case is a negative 0.004. B is 0.35, and C is 1.5. All right, next step, let's plug everything into that quad formula, opposite of B. So we have x equals the opposite, so negative 0.35 plus or minus the square root, negative 0.35 squared minus 4 times negative 0.004 times C, which is 1.5. All right, that's all my discriminant. And then that is all over 2 times negative 0.004. All right, once again, guys, looks sloppy. I can pretty much guarantee you that the discriminant is not going to be a nice number. It's probably going to be irrational. Let's check it out. Negative 0.35 squared minus 4 times negative 0.004 times 1.5, and we get 0.1465. So not super ugly, but also not great. All right, but the calculator does all the work for us. So x equals negative 0.35 plus or minus the square root of 0.1465 all over, just to show you guys that you can do this in the calculator, 2 times negative 0.004 equals negative 0.008. All right. Last thing, I'm going to give these approximate solutions. It doesn't say in the directions where to round to, so we'll round to the nearest thousandths again. I just have to break this into 2 problems, type them in my calculator, and write down the solutions. Okay, so we have negative 0.35 plus the square root of 0.1465, enter, and then divide that by negative 0.008, and we get a negative 4.094, and this is meters. That does not make sense. You cannot throw a javelin negative 4 meters. So obviously the next solution is going to probably be my correct one, hopefully. Negative 0.35, minus, we already did the plus, square root of 0.1465, press enter, and then divide that by negative 0.008, and we get a huge number, 91.594 meters. That sounds like a very long distance to throw a javelin, but I'm sure it's correct. All right, so as we talked about earlier, this is called an extraneous solution, as in it doesn't make sense, it's impossible. So my solution, how far that javelin went, is this right here. All right, guys, make sure you guys get these completely filled out, show all your work, and make sure I get it by the end of the day on Friday. Bye.